Welcome to 6.5. This is the quadratic formula of the discriminant. We're going to solve quadratic equations by using the quadratic formula. First, let's start with what is the quadratic formula. So the idea is if you have x squared plus bx plus c equals 0, then you can solve an equation by saying x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So our first example, two rational roots. We have x squared minus 12x equals 28. First thing, it's not equal to 0, so we have to subtract 28 from both sides. Then we're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1, b is negative 12, and c is negative 28. So we can substitute in our values. We're going to simplify. Negative 12 squared, that's 144. Negative 4 times 1 times negative 28 is 112. Minus negative 12 is positive 12, and on the bottom you get 2. Okay, so 144 plus 112 was 256 inside of the square root. The square root of 256 is 16. And then we can write as two equations. 12 plus 16 divided by 2, 12 minus 16 divided by 2, and then we get 14 and negative 2. So our solutions are negative 2 and 14. One rational root. So you got x squared plus 22x plus 121 equals 0. So we have it solved to equal 0. We can separate. A is 1, b is 22, c is 121. We can do negative b plus or minus the square root of b squared minus 4ac all over 2a. We can simplify. 22 squared minus 4 times 1 times 121 is actually 0. So you get negative 22 plus the square root of 0, negative 22 minus the square root of 0, which is just negative 22 over 2, which is negative 11. So our answer is negative 11 here. Irrational roots. Or a is 2, or b is 4, or c is negative 5. So when we substitute in, we can simplify. 4 squared minus 4 times 2 times negative 5 is 56. This is negative 4 plus or minus the square root of 56 over 4. Square root of 56, that simplifies down to 2 square root of 14. And then we notice negative 4, 2, and 4 all divide by 2, so we can simplify the fraction. We got negative 4, negative 2 plus square root of 14 over 2, and negative 2 minus the square root of 14 over 2. Complex roots. So here we add 13 to get it equal to 0. A is 1, b is negative 4, c is 13. We replace and we simplify. Negative 4 squared minus 4 times 1 times 13 is negative 36. Square root of negative 36 is 6i. So this is, they all divide by 2. So we have 2 plus 3i and 2 minus 3i. The next big part is understanding the discriminant. The discriminant is the b squared minus 4ac. It's what's underneath the square root. If it's greater than 0, then you get two real rational roots. If it's if it's a perfect square. If it is greater than 0 and not a perfect square, you get two real irrational roots. If it's equal to 0, you get one real rational root. If it's less than 0, you get two complex roots. So, describing the roots. We're going to do b squared minus 4ac. A is 9, b is negative 12, c is 4. Then we substitute into b squared minus 4ac. Simplify, we get 144 minus 144, which is 0. The discriminant is 0, so there is one rational root. Next one, a is 2, b is 16, c is 33. We substitute in, and then we simplify. We get 256 minus 264, which is negative 8. The discriminant is negative, so there are 2 complex roots. Next one, negative 5x squared plus 8x minus 1. So we have negative 5 for A, B is 8, C is negative 1. Substitute in 64 minus 20, which is 44. The discriminant is 44, which is not a perfect square, therefore there are 2 irrational roots. Next one, negative 7x plus 15x squared minus 4. We want to rewrite this so that it's in x squared form. The idea is A is 15, B is negative 7, C is negative 4. Substitute in, we get 49 plus 240, which is 289, which is a perfect square. It's 17 squared. Therefore, there are 2 rational roots. Okay, last idea is the concept summary. So graphing can be used sometimes to solve, but only if an exact answer is not required. Factoring can sometimes be used to solve, only if the constant term is 0 or if the factors are easily determined. Square root property can sometimes be used for equations in which a perfect square is equal to a constant. Completing the square can always be used. It's useful of the form ax squared plus bx plus c equals 0, where b is even. Quadratic formula can always be used. It's useful when other methods fail or are too tedious. So decimals is the idea. Good luck with quadratic formula.